Welcome back to Coffeesodes. You're listening to episode 31, and today we're going to be talking about something extraordinary.
Yeah.
So grab your coffee, get comfy, and if you haven't already, check out the episode description for some background on what we're going to be talking about today.
Ready to jump in.
Absolutely. For our new listeners, I'm Josh.
And I'm Kelly.
All right, Kelly, today's deep dive is all about what it takes to leap from the edge of space.
Oh, yeah.
I mean, can you even imagine the feeling?
Yeah.
Standing at that altitude, looking down at Earth, and then taking that plunge.
Yeah, it's wild.
It boggles the mind.
It's a truly mind-boggling feat, and we're going to explore two iconic jumps today.
Yeah.
Captain Joseph Kittinger's jump back in 1960, and then Felix Baumgartner's record-breaking leap in 2012.
Wow.
Both of these guys basically took a giant leap for humankind, you know?
I love that. A giant leap for humankind. Perfect way to put it. Okay, so let's start with Kittinger. What made his jump so groundbreaking?
Well, remember, this was 1960. Space travel was in its infancy, and we were just beginning to understand what the human body could withstand outside of Earth's atmosphere.
Yeah.
Kittinger's jump wasn't just about breaking records, it was about gathering crucial data. It was about pushing the boundaries of human exploration.
So he was kind of like a human guinea pig for space travel.
In a way, yes. He was testing the limits of human endurance and helping to pave the way for future space exploration.
But how did he even survive a jump from that altitude? Isn't space practically a vacuum?
It is incredibly hostile up there, but let's break it down.
Okay.
Imagine you're jumping off a diving board.
Okay.
The higher you climb, the more potential energy you have, right? As you fall, that energy transforms into kinetic energy, the energy of motion. Now imagine that diving board is at the edge of space, and you're plummeting towards Earth at incredible speeds.
Okay, I'm starting to get the picture. But there's no water to break your fall at the end of this dive.
Right?
So how do you slow down from those insane speeds?
That's where air resistance or drag comes in. Think about sticking your hand out of a car window. The faster you go, the harder it is to push against the air.
Uh-huh.
The same principle applies to a falling skydiver.
So the air itself acts like a brake.
Exactly. And here's where it gets really interesting.
Okay.
As you fall from extreme altitudes, you're passing through drastically different layers of the atmosphere. At the edge of space, it's practically a vacuum super thin air.
Right.
But as you descend, the air gets denser and denser.
Okay.
This change in air density has a huge impact on how fast you fall.
So the air is actually helping to slow you down.
Yeah,
That's wild.
it is.
What was Kittinger's experience like as he fell through those different layers?
Well, he was free-falling for over 4 minutes before deploying his main parachute.
Wow.
Imagine the feeling of the air getting thicker around you, the temperature changing the sound of the wind rushing past. And keep in mind, he was wearing a pressurized suit similar to what astronauts wear to protect him from the extreme conditions.
Yeah, that's intense. I can't even begin to imagine. 4 minutes of free fall. So was he just plummeting straight down the entire time?
Actually, no. One of the biggest dangers of a high-altitude jump is going into an uncontrolled spin. That's why Kittinger used a small stabilization parachute.
A stabilization parachute.
Yeah.
That's fascinating. I didn't know they even had those back then.
It was a crucial piece of equipment for his safety.
Right.
This smaller parachute helped to keep him stable and prevent him from spinning out of control. He deployed it just 16 seconds into his free fall.
Wow. So he was basically free falling for almost 4 minutes with just that little parachute keeping him steady.
It's pretty incredible, right?
It is.
Now, while Kittinger's jump provided a wealth of data and helped to pave the way for future space exploration,
Right.
there were some inconsistencies in the reported details of his jump. For example, some accounts claim he broke the sound barrier, which, based on the data, isn't accurate.
Wait, so did he or didn't he break the sound barrier?
Yeah, that's where the science gets a little tricky. Scientists were able to create simulations of Kittinger's jump using real-world data about atmosphere conditions and aerodynamics.
Okay.
These simulations showed that he reached incredibly high speeds, but not quite the speed of sound.
So the simulations kind of debunked the myth that he broke the sound barrier.
Exactly. And remember, the speed of sound actually changes at different altitudes due to variations in air density and temperature. It's not a constant value.
That's something I never really thought about. It's amazing how complex all of this is. So Kittinger's jump was all about pushing boundaries and gathering data for future space travel.
Right.
But what about Baumgartner? What motivated him to jump from even higher?
Baumgartner was all about pushing the limits of human potential. He wanted to break records to achieve something no one else had done before. And crucially, he wanted to break the sound barrier. And that's exactly what he did. Baumgartner's jump was a monumental feat of human daring and scientific precision. He jumped from a staggering 39 kilometers, significantly higher than Kittinger, and he did it without a stabilization parachute.
Hold on. No stabilization parachute. That's insane. Why would he take that risk?
It was a calculated risk and a necessary one if he wanted to break the sound barrier. The stabilization parachute, while crucial for safety, would have created too much drag, preventing him from reaching those supersonic speeds.
So it was a trade-off between safety and achieving his goal.
Precisely, Baumgartner and his team knew the risks, but they were meticulous in their planning and preparation. They used sophisticated simulations similar to the ones we talked about earlier to model his descent and predict the challenges he would face.
I can only imagine the nerves of steel it must have taken to step out of that capsule, knowing there was no safety net, so to speak.
Absolutely. Baumgartner was pushing himself to the very edge of human endurance, both physically and mentally.
So walk me through his descent. What was it like for him to break the sound barrier?
Well, as Baumgartner fell, he accelerated rapidly, just like Kittinger. But because he didn't have the stabilization parachute, he started to spin uncontrollably.
Oh, wow. I remember seeing footage of that. It looked terrifying.
It was a very dangerous situation. He was spinning so fast that he experienced intense G-forces, putting immense strain on his body. But thankfully, he was able to regain control after falling to about 19 kilometers.
What a relief. So after he regained control, did he just continue falling until he reached a safe altitude to deploy his main parachute?
Exactly. But the most incredible part was yet to come. As he continued to fall, he eventually reached the speed of sound.
Yeah.
Can you imagine what that must have felt like?
I don't even know.
To be hurtling through the air faster than the speed of sound?
I get goosebumps just thinking about it. What did the simulations show about that moment? How fast was he actually going?
The simulations confirmed that Baumgartner reached an astonishing speed of Mach 1.25.
Mach 1.25. That's over 1,500 kilometers per hour. I can't even comprehend that kind of speed.
It's mind-blowing, isn't it? And remember, the speed of sound changes with altitude, so it wasn't a constant speed. He was accelerating and decelerating as he passed through different layers of the atmosphere.
So he broke the sound barrier, regained control from a terrifying spin, and eventually deployed his parachute safely. It's an incredible story of human courage, determination, and scientific ingenuity.
I couldn't agree more. Both Kittinger and Baumgartner pushed the boundaries of human potential and expanded our understanding of what's possible.
Okay, so we've talked about the physics of these jumps, the incredible speeds, the dangers, and the technological marvels that made it all possible. But what about the psychological impact? What kind of mental fortitude does it take to jump from the edge of space?
That's a great question, and it's something that often gets overlooked. Imagine the mental preparation required to face that kind of challenge. The isolation, the sensory overload, the awareness of your own vulnerability. It's truly remarkable that anyone would willingly put themselves in that situation.
Yeah, it takes a special kind of person, right? Someone who thrives on pushing limits, exploring the unknown, and testing the boundaries of human experience.
I think that's a great way to put it. These are individuals who aren't afraid to face their fears and embrace the unknown.
They're almost like modern-day explorers venturing into uncharted territories.
Yeah.
It's inspiring, really.
It is inspiring, and it makes you wonder what's next. What other boundaries will humans push? What other frontiers will we explore?
That's a great question. With commercial space travel becoming more accessible, do you think we'll see more people attempting these kinds of high-altitude jumps in the future?
It's certainly a possibility. As technology advances and space tourism becomes more commonplace, we might see a new breed of adventurers seeking to follow in the footsteps of Kittinger and Baumgartner.
Wow, that's an exciting thought. But what new challenges might those future high-altitude adventurers face?
Well, they'd be dealing with even more extreme conditions and altitudes, for one thing. We might need to develop new technologies and equipment to withstand the harsh environment of space.
That makes sense. I mean, even at 39 kilometers, Baumgartner was pushing the limits of what current technology can handle. What about the human body? Can we even withstand the forces and pressures of falling from even higher altitudes?
That's a big question. We'd need to understand more about the physiological effects of extreme freefall.
Yeah.
How would the human body cope with even higher G-forces, more extreme temperature changes, and prolonged exposure to near-vacuum conditions? These are all areas where further research is needed.
Wow, so many unknowns. It's exciting and a little bit terrifying all at the same time.
It's the perfect blend of science and adventure, wouldn't you say?
Totally. And who knows, maybe those future high-altitude jumps could lead to some groundbreaking discoveries. We might learn things about aerodynamics, space travel, or even human physiology that we never even imagined.
I think you're right. Every time we push the boundaries of what's possible, we open up new avenues for discovery and innovation.
Well, Kelly, this has been an incredible deep dive. Thanks for taking us on this journey into the world of high-altitude jumps.
It's been my pleasure, Josh. Always a thrill to talk about these awe-inspiring feats of human courage and scientific endeavor.
And for our listeners, if you're as fascinated by these jumps as we are, be sure to check out the episode description for links to some of the research we discussed. And if you could jump from the edge of space, would you take the leap? Think about it.